हेलो दोस्तों। आज हम लोग रेशनल नंबर और इरेशनल नंबर प्रूफ करने के लिए देखेंगे। सो बिफोर गोइंग टू स्टार्ट दिस होल सेशन, फर्स्ट ऑफ ऑल वी विल रिमाइंड एचसीएफ को पहले रिमाइंड कर लेते हैं आखिर एचसीएफ में क्या क्या फैक्टर्स होते हैं। सो फर्स्ट ऑफ ऑल वी विल नो अबाउट दिस एचसीएफ, दैट मीन्स highest common factor. And if you remind, I told you in earlier classes that the factor is the number which divides any particular number. Suppose we have 6, so 2 and 3 and 1 and 6 are their factors. So it means that this factor will divide this 6. So similarly, when we take two numbers and they have common factors, so the highest common factor is called HCF. Suppose we have 6 and 15, so their factors will be, so their factor will be 2 and 3 and 3 and 5. So common factors here are 3, so that's why we say the HCF of 6 and 15 is 3. So similarly happen in the case of while we are solving irrational number or while we are solving rational number. So before going to study these topics, we should know about this topic also. So what are the factors or what is the HCF? HCF means that more than one factors are common with the other number. Suppose we have 6 and 12 and its HCF is 3, then we say its factors are common 1 and 3. So this is the HCF. So now by the definition of rational number, we had studied about the rational number, that the rational number is in the form of P upon Q, whereas P and Q, the ratio of P and Q and the HCF of P and Q is 1. It means that no other factors are common. No other factors are common. No other factors are common. If other factors exist, it means that they are not a rational number. Suppose we have a number having common factors, so we don't say that they are rational number. Again, if we have any common factors, it means that it will divide the number. Now, how we will solve this? Root 2 is an irrational number. How we will? So this root 2 is an irrational number. So before doing this, first of all, we should have to know about that we can't solve it directly saying that it is an irrational number. Root 2 is an irrational number. Root 3 is an irrational number. Root 5 is an irrational number. We don't say. So first of all, what we say that we assume that it is a rational number. What we assume? We assume that it is a rational number. So suppose this root 2 is a rational number. And by the definition of rational number, what we know? It is a form of where it is in the form of P upon Q, where HCF of P and Q is equal to 1 and Q not equal to 0. Again, what we assume? We assume root 2 is a rational number where it is in the form of P upon Q, where HCF of P and Q is 1 and Q is not equal to 0. So, by proving it, we can write it as root 2 is equal to P upon Q because we considered it as a rational number. So P upon Q. On squaring both sides. So the question arises here that why we squared it. So you know that root 2, it isn't a perfect number. So what we do to get a perfect number. So by squaring it, it means that by multiplying the root 2 with the root 2 we get 2. So it can be very easy. It can be very easy to identify the nature of the number, nature of the real number. So on squaring both sides we get root 2 square and p square upon q square. So we get 2 is equal to p square, and again 2q square is equal to p square. Now we can see here this 2 is multiplied with this q square. It means that this whole is a product of this whole. The product of this whole multiplication is p square. So 2 will divide or 2 divides p square, because previous classes I had told you when we multiply any number, so the product will be divided by that any number, which is called its factor. So 2 divides p square, so 2 will divide p also. So what we find here? We find that 2 is a factor of p. 2 is a factor of p. Again, what we say here, assume it as an equation first, and consider assume this as an equation 1 and consider p is equal to 2a, 2b, whatever you want to take, you can take. So p is equal to 2a, and again put this value in equation first. So by putting this value we will get, we will get 2q square is equal to 2a to the whole square. So 2q square is equal to 4a square, so 2 cancel, q square is equal to 2a square. Here again you can see 2 divides q square, so it obviously divides q, and again what we find, 2 divides p, 2 divides q. So it's mean that the factor of p and q are common, which is 2. The factor of p and q is 2, which is common here. So what we have assumed earlier, that it's SCF of PQ is 2 here. But what we have assumed? We assume that SCF of PQ is 1. So a contradiction occurred here. Sir. And why this contradiction occurred here? Because of we assumed it is a rational number. So suppose we had assumed it irrational number, occurrence of contradiction wouldn't happen. So we will say this contradicts occurred due to assuming root 2 is a rational number. So it is a irrational number. Proved. So this is how we can prove all the irrational number related to